Yes. So welcome back students to one more session of your 2014 paper. So we have already started with the 2007 paper. We have reached till here. As and when I complete 2014, we'll finish it off by doing all till 2017, and then we'll go back to the next chapter. Yes. So when in 2014 paper, there's a direct question given to us. Easy, isn't it? So let us see the first question. Write the products formed when acetaldehyde reacts with the following reagents. Okay, when such question is given to you, most of the students, what do? They try to write the general form, or they're going to copy a wrong example. Please don't do that. Directly they've given acetaldehyde. You have to add this and show that reaction. Simple. So take that acetaldehyde first. We have already done these reactions in your chemical properties of or nucleophilic addition reactions of aldehyde. It is the same here, right? So this is hydrogen cyanide. First important thing, there's a shift of the bond here. When there's a bond shift, this attains partial positive charge and this gets partial negative charge. Again, there's a cleavage of the bond here. This becomes partial positive and partial negative. So the positive end goes and attacks oxygen. The negative end goes and attacks the carbon atom or the carbocation. So what do you get? Just see, CH3 is still there, your carbon, your hydrogen, so O and H, isn't it? OH, and C is attached to your cyano. This is called cyanohydrin. That's it. Simple question. Right, let us come back and do the next one. When I am taking the second example, I have to take again acetaldehyde. H, I have to add a compound called hydroxylamine. This is hydroxyl, see, hydroxylamine. So let us write hydroxylamine. So as soon as you find hydroxylamine, elimination of water. We have studied under reactions involving elimination of water or elimination of oxygen in the form of water. So this is one of the reaction from that. So what do I get? I get minus water. So what should I write? I have to be careful, nothing to do. Just eliminate water and copy the same. CH3 is like that, your carbon is here, H is here, your double bond is still existing. Please remember that. Double bond and NOH. So what is this compound? Here we have got it from ethanol, right? So this is ethanol cyanohydrin, because I picked up that. Here what is this? Hydroxylamine to oxime. This is called oxime. Which oxime is this? It is called ethanol oxime. That's it. So this is this one, the ethanol oxime. Done? Yeah, simple. Now I'm done with this one. Let us start with the third one. What did they give us? They've given me CH3CH in the presence of dilute sodium hydroxide. Whenever you see dilute sodium hydroxide or barium hydroxide, only thing which should click you is aldol condensation, right? We are going to use the base. I also showed you the mechanism of aldol condensation. What is the role of sodium hydroxide, or what is the role of the base in the particular reaction? Please watch that video for aldol condensation. Once you understand aldol, it's easy to whichever example they give you. So I'm going to start with that particular reaction. Now write down acetaldehyde with in the presence of sodium hydroxide. It's the same story again. I'm doing the third one. So what should I do? I'll write the question. I'll copy the question. Acetaldehyde in presence of dilute NaOH. Simple, right? First you're going to take acetaldehyde. Write in this way, right? Those who are watching the video for the first time, I'm showing it again, right? Again, CHO. I'm taking two molecules of acetaldehyde. Now CH3 is here, so I'm writing CH3 here, aldehyde here, CH3 here, aldehyde here. So try to write H2 and H. Simple. Now shift of bond here. So immediately this hydrogen from here is going to shift to this molecule, forming an aldol. So this whole thing occurs in the presence of dilute sodium hydroxide. If they give you barium hydroxide, write barium hydroxide here. So what do we get? I'm going to get CH3, C, your OH and your hydrogen, and CH2 is still existing, and CHO. Here I've got aldehyde and alcohol, so it is called aldol. Which aldol is it? 1, 2, 3, 4, isn't it? Yes. So it is called 3-hydroxy butyraldehyde. Butyraldehyde. 3-hydroxybutyraldehyde. Now further, what do? When you heat this hydrogen from here, observe again, first time I shifted one hydrogen, the second time also I'm going to shift one more hydrogen from this, elimination with this bond. So you get minus H2O, and the bond which is here drops in here. So what do you get? CH3, CH, double bond, CH and CHO. What is this compound? 1, 2, 3, 4. Yes. So bute. Which bute is this? After 2, double bond, 2. Enol. En. This is en for double bond, al is for aldehyde, bute to enol. This is your aldol condensation reaction. Every paper almost they've given aldol condensation because that's a characteristic reaction of the aldehyde as well as ketones also. Ketones either form I accept, but aldehydes in specific reaction aldol. So please note it. So we are done with this. Now let us come back and start the next one. What is the next thing? I have to do simple differentiating test. Easy, simple differentiating test as soon as such compound is given to you. So I'm solving the second part. First one, take, as I said, take again the heading benzoic acid. Copy phenol. I did this reaction earlier also. Now you are going to write the formula for benzoic acid, COOH. Write the formula for phenol. So the best test, as I said earlier, the best test to differentiate phenol and benzoic acid is sodium bicarbonate test. The evolution of the effervescence or the carbon dioxide gas simply clearly says that the presence of acid group in that, or the benzoic acid group in that. So most important, test with NaOH. This is the best example you can pick up. Whenever you see acid and alcohol, pick up this test. Sodium bicarbonate. So this is your COOH plus NaHCO3. So what do you get? There's a cleavage of the bond here. Right, this comes out in the form of, just see, this comes out in the form of water and carbon dioxide. What do I get? I get first sodium benzoate. This is COONA, sodium benzoate plus water, as I said, and this is your carbon dioxide. This carbon dioxide is where you observe the effervescence in that particular test tube, effervescence. But phenol test with NaOH. I also already gave a reason in the earlier video. In my earlier video, I've already given the reason for why is it not showing the sodium bicarbonate test. So no reaction. So you can say this too. This is a differentiating test because they've asked for 1 mark and 1 mark. Basically, your aldehyde chapter is for 5 marks, isn't it? 1, 2, 3, 4, 5. So 1 mark, 1 test is enough for you all. So this is how you're going to show it. So we are done with this. Let us start with the next one. Propanol and propanone. Right? So as soon as this compound is given to you, try to write again the same thing. Heading propanol and propanone. Okay, so I have to write the formula. CH3, CH2 and CHO is propanol. Ketone, propanone is a ketone, isn't it? COCH. This is your ketone, correct? Prop means 3 carbon and your own is, this is giving you ketone. Ketonic functional group is own. Now, I very well know which group is this aldehyde group. What is this ketonic group? Now, confusion. This always most of the students, they ask me to compare this with this. So you can write the test which this shows and compare it with that, saying that it will not show the reaction. Simple. So aldehydes, we very well, it shows tolerance test, right? This will show Felling's test. Correct, right? So will ketones show those tests? No, isn't it? So I've done this video in this particular thing. You can watch the video. Tolerance test also I did, Felling's also I did. So please watch that video for that differentiation test. Write that reaction here, right? Simple.